You can start.
Chindesh sir, should I start or VC sir will join?
Just VC sir is joining, and
Now you have seen the team.
Yes sir, yes sir.
So start with the Kemchan San.
クラクションとするやん。インドはクラクションのあれだから。
Shinde San, start.
In the meeting.
just a minute, we will start.
Yeah, please.
Sir, VC sir is joining the meeting.
Huh?
Our Vice Chancellor sir is joining the meeting.
Vice Chancellor.
Yes sir, Vice Chancellor sir is joining the meeting.
He just admit. Okay.
Yes, yes, sir. Should I start sir?
Yeah.
Yeah, you can start.
Good afternoon, Japan. Hello and welcome to everyone present here. Myself, Engineer Kemchan Kapgate, Research Associate at the BET, NAHEP Vasantrao Marathwada Krishi Vidyapit Parbhani. I have privilege for organizing this meeting on behalf of Vasantrao Naik Marathwada Krishi Vidyapit Parbhani, the Center of Excellence for Digital Farming Solutions for enhancing productivity by robots, drones, and AGVs at a technical meeting on grafting robot by Kusakabe Kikai, Osaka, Japan. Today, it's a great pleasure moment that Honorable Vice Chancellor Dr. Ashok Dhawan sir, Vice Chancellor sir, Dr. Ashok Dhawan sir, Vasantrao Naik Marathwada Krishi Vidyapit, as the chairman for this meeting with Mr. Kanshu Minohara, President of Kusakabe Kikai Company Limited, Osaka, Japan, and also Dr. D.N. Gokhale, Director of Instructions and Dean, Vasantrao Naik Marathwada Krishi. Participating from Kusakabe Kikai Company Limited are Mr. Shiva Shankar, Member of Global Board, Kusakabe Kikai Company Limited, Mr. Yuji Masaki, General Manager, Agricultural Machinery Division, Mr. Koji Shimada, Assistant General Manager, Agricultural Machinery Division, Mr. Jugo Minohara, Group Leader, Sales Engineer, Agriculture Machinery Division, Mr. Mumado Orodilo, Overseas Sales Division, Mr. Hidaki Murakoshi, Group Manager, Overseas Business. We all research associates, senior research fellow, junior research fellow, junior engineers, and technical staff under the guidance of Principal Investigator Dr. Gopal Shinde, NAHEP Vasantrao Naik Marathwada Krishi Vidyapit, welcomes you to all. Kinichuwa Subato Kesoka. Now I would like to request Principal Investigator of NAHEP, Dr. Gopal Shinde sir, to give brief introduction of the NAHEP project.
Very good morning to India.
Good morning. Good morning.
Good morning. Good morning to Japan. Good afternoon to Japan. Respected Chairman of with Kusakabe Kikai Grafting Robots Limited and Vasantrao Naik Marathwada Agriculture. I deeply sense make this event graceful because of Honorable Vice Chancellor Dr. Ashok Dhawan sir, who is a Vice Chancellor of this university, leading the nation pride and leading the agricultural spectrum. I welcome to Kanshu Minohara san for this function today, for this meeting today, for being with us in this meeting to introduce you a World Bank project. I also welcome Director and Dean of this VNMKV, Dr. D.N. Shiva Shankar san, Dr. Yuji Masaki, Dr. Koji, Dr. Jugo Minohara san, Mamadou Auri Dailo-san, Hidekai Murakoshi-san, all technical staff, all core team members, I warm welcome on behalf of National Agriculture Higher Education Project. This is sponsored by Indian Council of Agriculture Research, New Delhi, India, and World Bank in adjunctment with this project. This project is titled as Digital Farming Productivity Enhancement Solution, Drone AGV. We are very much privileged to have a big project of 18 crores of this worth funding project. We are establishing a center of excellence for establishment of the digital technologies to enhance the agricultural productivity. This project is Vasantrao Naik Marathwada Agriculture University, Parbhani, India. I am having a great privilege to honor National Director of Director of NAHEP and Dr. Prabhat Kumar, who is a national coordinator of this project. I am really thankful to Edward, who is a World Bank coordinator for this project. I am happy to say about this project. This project we are established with the 3 divisions: Agri-Boat Division, Agri-Drone Division, Agri-AGV Division. We are participating 21 core team members, disciplines of agricultural. We are established 5 portfolios in this sector. First portfolio is climate-based decision support center. We call it as a CDKS. Second is a seed and seedling process nursery automation. Third is the smart portable machinery division. And fourth is food processing automation center. We are also establishing an instrumentation this project. We are having a knowledge partners, Indian Institute of Technology, Bombay, Indian Institution from India. We are also universities from Washington, university from Spain, university from Netherlands, university from Belarus, university from Australia, university from Israel. We are having different scientific are working in grafting technologies. Our Honorable Vice Chancellor Dr. Ashok Dhawan sir inspired us to have a different types of grafting, citrus fruits grafting, citrus fruit plants grafting. We are having different types of plant species, floricultural grafting, different types of grafting we are interested in. Our team, NAHEP team, have a 15 number of engineers working with the different disciplinary knowledge. Electronics engineer, mechanical engineer, mechatronics engineer, agriculture engineer. Then we are also associated with the electrical, electronics, computer engineering. We are gathering all those talents to work for the different agricultural innovation technologies which will help us to increase the productivity. On this occasion, I really thanks to the Japanese team, Kekai Grafting Robotics from Japan. We are very serious about grafting technology. We are associated with South Korea for this grafting technology to work together, and we began with the and Solansia families, Bitasi and Solansia families plant species. we are gathering them to have spaces. I'm very happy to see the technology that has been developed by Japan is a very much proudful. And I had been to Japan, Narita, Tokyo, and Osaka. I went to Osaka to visit the different. That time I visited the of Tokyo. I am very happy to organize, to have a collaboration with KKK grafting robots. So I'm very serious.
経営はちょっとあげるけど、すごい機械全部要素あるやな。なんか言うな。
We will be very much serious to make this robot, grafting robot, for the collaboration with KKK. I'm really thankful to our global board director, Dr. Siva Shankar, who is always inspiring, always connecting, always talking, always having gathering for the discussion on grafting technology. To get this opportunity grab in this pandemic situation. We will be working together, maybe online Zoom platform, maybe things which will be collaborating to each other. So I really thanks to all of you to be with us, our core team member, technical staffs, those who are gathered here. They are having a discussion points in this meeting. Privileged to have a discussion on technical discussion related to grafting robots. It may be a 2 species or maybe a species which can be grafted. Whether there is a challenge we are accepting to gather the more than 2 species for the grafting process. And more, we are interested in grafting citrus groups of families, citrus plant species to be grafted. So I welcome you all on behalf of National Agriculture Higher Education Project, DFS, to gather and get a enjoy of this meeting today. So thank you one and all.
Thank you, Dr. Gopal Shinde sir, for briefing about the NAHEP Center.
ちょっと止めてさ、ちょっとだけもうさに翻訳通訳するからちょっと時間もらわないから言ってくれへんけど。
Hello, Japan team, can you please mute your sound? Now may I request Dr. D.N. Gokhale, Director of Instructions and Dean, Vasantrao Naik Marathwada Krishi Vidyapit, Parbhani, to address the gathering.
Good morning, India. Good afternoon, Japan. Chairman of the today's function, our Honorable Vice Chancellor, Dr. Ashok Dhawan sir, President Kanshu Minohara, Global Board Director, Member Mr. Shiva Shankarji, Kusakabe Kikai Company Limited, Osaka, Japan, and Grafting Robot Team, Kusakabe Kikai Company Limited, Japan. Dr. Gopal Shinde, Principal Investigator, NAHEP Center, and his team members, and my colleagues. I heartily welcome you all on behalf of Vasantrao Naik Marathwada Krishi Vidyapit, Parbhani. We are very happy to associate with Team Kusakabe Kikai Company Limited, Japan. We like to proceed for mutual collaboration with Team Kusakabe Kikai Company Limited, Japan. Our university is having more than 3,000 hectares of land in one campus at Parbhani. In our university, we are having the 200 PG students completing their post-graduation and PhD students at Parbhani campus. And total sum from all the campuses is more than 5,000 students and 266 teaching faculties in our university. We established World Bank research project for robot, drones, and AGVs applied in agriculture. We are happy to invite you for mutual collaboration and combined research activities for developing the grafting robotic technology in our university. I appreciate the efforts taken by Dr. Gopal Shinde, Principal Investigator of NAHEP, and his team for initiation for collaboration of activities with this team, Kusakabe, Kikai, Japan. I am very much thankful to our beloved Vice Chancellor, Dr. Ashok Dhawan sir, that they always keep us dynamically working in digital technology innovations in agriculture. Thanks to the organizers for allowing me to express my views in this meeting. Thank you very much.
Thank you very much, sir, for always inspiring us and support to conduct academic and thematic research activities. Thank you, sir. Now I request Dr. Gopal Shinde to introduce Honorable Vice Chancellor, Dr. S. Dhawan, sir.
Today, it's a pleasuresome moment, and it's fortunate to have a great opportunity in this era, in this decade, that we got a very dynamic, young, energetic, Honorable Vice Chancellor, who is a soil scientist of this nation. In presenting so many kinds of research activities, academic activities, and extension activities. And I'm very glad Honorable Vice Chancellor is a alumni of Indian Institute of Indian Council of Agriculture Research affiliated Research Agricultural Research Institute. We are very much enthusiastic to listen from our Honorable Chairman for this today's meeting to guide us in this regard for the development of different grafting and plant, because our Honorable Vice Chancellor is very much affectionate with the plants and plant species. He is having an interest in developing the different types of plants as a forest ground in the university campus. So I am just making this introduction because Sir himself is a idol for the agriculture, and his interest will inspire all of us to gather together for technical discussion. So I request Honorable Vice Chancellor Sir to address this gathering for the technical discussion with Japan. May I request Honorable Vice Chancellor Sir to please address us. Thank you, sir.
Okay, friends, am I audible to you?
Yes, sir.
Okay. So, good morning to every one of you as per the Indian local time, and good afternoon to our Japanese colleagues who are with us today for the technical discussions. As we know that Dr. Gopal Shinde has briefly narrated a project which is a very ambitious project funded by World Bank, and we have been fortunate enough to be identified by the ICAR as one of the center to implement this very ambitious project under the National Higher Education Project. And since 1 year, under the aegis of these projects, we have been conducting several technical workshops and training programs. Around the globe, we have been able to identify some of the knowledge partners, and I'm very happy to see today that the team from the Japan has joined us in this particular new area of research, that is robotics. You know, the Indian agriculture has entered into the digital agriculture since few years back, and a lot of digital input is called in designing and developing the technologies in the years to come. We are involved in the precision farming, and a lot of digital input is required to improve the efficiency and preciseness of various agricultural operations. And robotic is one area where we look forward for our knowledge partners from the Japan that designing and development of the robots, digital other tools. And at the same time, we expect them to train our own colleagues who are working in this exciting area. It has been mentioned by my colleague, Dr. Gokhale and Dr. Gopal Sinde, that apart from training the faculties of our university, we are also interested to train our young scientists who are doing their postgraduate research, leading to degree of MSc and MTech and PhDs. And it is in this context, I'm very happy and delighted to see the team from the Japan that they have a rich experience in the design and development of the robotics in agriculture. In fact, I look forward for your continued collaboration with us. Because of this pandemic situation, we are meeting today on the digital platform, but I hope that in days to come, the situation will come to normalcy, and we'll be very happy to have our colleagues globe who could physically come over here, train our manpower. And at the same time, I also look forward for the opportunity to take our scientists to visit different laboratories of the leading universities of the world. And this is how we go on building the partnership in the exciting area of digital agriculture. So with these words, once again, I welcome all the participants in this today's interview. I look forward to our continued collaboration with our Japanese colleagues working in the exciting field of digital robotics and design and development of robots in agriculture for various operations. Thank you very much.
Arigato gozaimashita-san.
Thank you very much, sir, for your valuable insights on the topic. Your inspiring words will definitely encourage us to go ahead. Thank you, sir. Now I request Dr. Sivasankar, sir, member of Global Board, Kusakabe Kikai Limited, to introduce Kusakabe Company Limited and President, Mr. Kanshu Minawara and team of the Kusakabe Kikai Co. Limited.
Yeah.
Dr. Sivasankar, sir.
Yeah, good day. With great pleasure, may I introduce Kusakabe Kikai Company Limited, called as KKK Japan, to this August gathering. KKK Japan has been a pioneer in manufacturing the state-of-art equipment for high pressure boiler plant worldwide for well over 50 years. KKK is a respected brand worldwide by the customers for the customer-centric, ethical and value-driven continuous development, business development with new high technology organization. Now KKK has entered and forayed into the agricultural field, successfully launching grafting machine for tomatoes after long years of research and development. Now I may run through the team which you already mentioned. Our company is led by our president, Kanshu Minawara-san, supported the grafting team, supported by the Yuji Masaki-san, General Manager, Agriculture Machine Sales, Koji Shimada-san, the development side, Assistant General Manager, Agriculture Development, Jugo Minawara-san, Group Leader, Agricultural Machinery Sales Engineer, Mamodo Oiro Dailosan Overseas Business Sales Division, and Hideki Murakoshi-san, Group Manager, Overseas Business Division. Along with, of course, myself as a part of the team of KKK Japan. May I now request our coordinator again compare.
Okay. Thank you, sir. Now I request the team members of KKK to begin with their presentation. KKK team members, please.
Remember. Hello.
Presentation.
Yeah.
Yeah, go ahead.
I'm a president of Sakabe Kikai. My name is Minohara. These are our members. And first, thank you very much for the taking opportunity of this meeting today. Robot GRF will be probably the first of devices in the world to be put into practical use in the agriculture field. Recently, the delivery is increasing mainly in Japan and Europe. And our company, and India is a very familiar country for us that we have been working with since 1970s. And we export many machines to your country. And now we are very happy to have an opportunity again to contribute to the development of agriculture in India through the supply of this equipment. So we are very, very happy to work with you. And we will try to give you our best effort to be success this project. Okay. Thank you very much.
Thank you, sir. Thank you very much.
Presentation.
ありがとうございました。
If you have any presentation, sir, then just share your screen and start with your presentation.
Presentation. Is it a company ourselves or for machine itself?
Grafting machine.
You mean the introduction of our company?
Yes.
Okay.
No, ちょっとあれって。
Introduction of the company and the equipment for the grafting.
Okay.
ほん
ならやろう。音で仕上げろ。
はい。
はい。これ。見えてるの？見えてるの。シェアされた。
Can you see the slide on the screen?
Yes, sir. Yes, sir. We are able to see. Make it in the presentation.
I'm relieved that everybody understands Japanese. Okay.
Could you begin with the presentation mode, sir?
Yes, it's just an introduction of our company, but before proceeding on, just a brief introduction of myself. Many people have introduced me, but my name is Giano.
Yes, sir.
And I'm from the overseas sales department. I will briefly do the presentation of our company. To begin with, let me first explain this. You can see at the beginning here, you used to call it Kusakabe Kikai, but usually we call it KKK. It's not the Ku Klux Klan. so we released with that. It's just a short name of Kusakabe Kikai that we usually call KKK. Okay. This is just to talk about some of our core value and concept and how we do business. Our business center approach is based on our customer satisfaction. That's the main purpose that we do business here, and all we do, the equipment we supply, it is usually based on the idea of we should satisfy our customers. That's the concept of our company. And along the way of the history we've been developing a lot of technology and accumulated a lot of know-how that we come up to put into the whole bunch of equipment we're supplying right now. So I will, at the end of the presentation, briefly introduce that, but we do pride ourselves to have become through the years an international organization that is contributing to the development, not only Japan, but many countries around the world. This is just a brief history of our company. I think our president have also highlighted this, that we have been in operation since 1966. And as we meeting with some Indian partner today, for you just information, we started to set up an Indian office in 1986. And since then, we've been in operation for more than 50 years, and just in India, more than 40 years, we have experience with the Indian local market. Just proceed on with the business segment of our company. Basically, we operate in two main fields. The first one is trading. As you can see, it's importing and exporting, as you call it. So this is just an example of one of the equipment that we're importing from Europe and introduces to the local market in Japan here. And the second area of business segment is engineering. Here we do the design and manufacturing a lot of industrial equipment that we will introduce later. This just a brief explanation of the trade and business we do here. For example, you can see a whole bunch of equipment that we list on the domestic trading here. We have, for example, dust collectors and hydraulic lifters and so on. I'm not going to list up all these things. On the international trading, also we have, for example, pressure tank, on film collector. And this film collector is the one I introduced earlier that we are importing from Europe. I'll proceed on the engineering business. In the engineering business here, our main markets are, as you can see here, it has a very wide range of market target. Here we have, for example, boiler manufacturer. That's one of the our main client for the equipment that we manufacture here. And we do also supply the construction machine manufacturer, building, bridge manufacturer, and so on. Just a brief example, as you see, I've listed a lot of target industries, but we just want to give a brief example because we not spend a lot of time talking about it. Just an example on the boiler manufacturing field. Here, I think it's better to see the video or to have an idea the kind of equipment we supply to this industry. So if you wouldn't mind, I just proceed with a video, maybe 30 seconds for you to have an idea.
Sensor とかソフトウェアを作るのが得意やって言うとき、プログラミング。了解近かったらこれ見たらどんな入手持ってんやろな。
If you have difficulty seeing the slide, please let me know.
Can you make it in presentation?
So sorry, I couldn't hear.
Can you make this video in presentation mode? Presentation mode. Presentation mode.
Oh, okay, okay.
That's fine. Back in.
Okay, you mean to replay the video again?
Oh,
Yes. Back in.
Mr. Gopal, can they display some of the grafting robots which they have already designed in their company and they are in the operation in the field? If they have some slides or maybe some videos
Yes, sir.
which they can share for
Yes, sir.
scientists,
Yes, sir.
please.
Mr. Jao,
Sorry, we couldn't hear what you said.
can you play the video of grafting robot?
Yes, we will, we prepare 2 different slides. This
Okay.
is the introduction of our company, and we will be doing another presentation on the grafting robot.
Back in.
Yeah, that will be better. Now we have got a fairly good idea about the company.
Okay,
Now
okay.
we are interested to see some of the grafting, robots which are designed by your company and
Okay,
which are
okay.
in the field.
Okay, okay.
Sutukina presentation.
Good.
Thank you.
Good Japanese.
The presentation.
Only Gopal knows the Japanese. We don't know anything about it. Yeah.
Actually, they want to learn us as Japanese, and they also are interested to learn Indian language. Well,
Okay. Can I proceed on with the presentation of the grafting robot?
Please.
Okay.
Please go
okay.
ahead.
障害が違ったら今日も週3だよな、これが。
そうですね。
でもロボットをちょっとやってるのを見せるとく意味があるんですな。多分この子に閉じなあるかわかんないじゃん。
そうそう、消さないとね。
Sorry, please hold on.
Vivan mein Nimeska. Second presentation.
Oh.
So translator. Translator.
うん、だと共有
されてない。見えてるのか。右の矢印。右のその矢印。
あ、イグジ
ミニマイザー。
イグジットで
それで、もちろんもちろん。
それでシェアスクリーン。
使って誰が分からへんな。シェアしたの。
Back in.
Good.
Back in.
Presentation model is still. Okay.
こんな感じで映ってる。
Can you see the slide?
日本語って。
ねそのようには映ってないけどね。
Slide does not come.
Hi.
Okay. That's the slide of the grafting robot that we call robot GRF.
結構長いなと思うな。もう G やったな。
Just to begin, this is just an introduction of the machine.
Shows you time.
Okay, the video you're seeing here is showing the takt time of the robot and how it runs. What we mean here by takt time is it starts from putting the grafted seeding into the tray. It goes to once the operator puts back the next tray, the next seeding into the tray. So the total takt time is about 8 seconds.
Kuroju Susa of a video. Kuroju Susa video.
Sorry,
Close,
can you?
a close video operation.
Close video operation. 見えてないのか。
Oh, so you couldn't see the video?
Not clear. No, it's operation not clear.
不平所になってくるやつ。
Okay, I will move on to the next slide. This is the structure of the machine that you saw here. And as you can see on the top here, again, this is the, for example, the Scion clamp, and we have the Scion cutting, but it's a bit difficult to see. And you have the different kind of parts here. You have rootstock cutting and the rootstock clamping. And you have on the right side here two buttons. You have the clamp button and the start button. But since you couldn't see it clear on the first video, I think we can move on to the next slide, maybe where you can have a better look of.
Saizakato operation specification.
Yes, this is the video about the operation of the machine. Okay, I know just watching the video, you will not realize the benefit of having this robot. So we put this slide here to sort of explain the benefit that comes along with this machine. The first thing we put on a lot of research on to stabilize the quality of this machine. As you can see here, it's more than 95% the success rate when you use this machine. And the second most important benefit of this machine is it helps increase the productivity. You have, for example, just an example here, it can proceed with 400 species per hour, but this is just per one operator. And the third thing is it's the flexibility of the machine. This is the design of the machine that makes it very flexible. And the fourth thing is the in terms of cost performance. Usually with those kind of machine, there are a lot of costs involved with operation and maintenance, but with this machine, that also is reduced. And you may wonder, for example, for spare parts and those kind of things that comes along with the operation of the machine. But for those kind of things, we do supply them. You don't have to worry about that.
Isa kato toa specification.
Sorry?
Isa kato toa tolerance.
Could you repeat again, please?
What is the scissor cut tolerance? Scissor cut tolerance.
You mean the tolerance?
Yeah. Bakai. Yeah. Yes. What is the scissor cut tolerance?
下見ダイヤ見たかなんか
タイヤ見た
Bakai.
You mean the diameter of the Scion in the rootstock?
Yes. Yes.
Okay, I think that's
Hi.
that's on the next slide.
Okay.
Okay, this answer, I think your questions here, you can have, for example, for the Scion here, we have the hidden position and the diameter. You can see the same diameter, and the difference of the diameter between the Scion and the rootstock within 4.5 millimeter. Does that answer your question?
Yeah.
Okay. And just for reference, you can see some of the standard specification for the rootstock in the Scion. The Scion on the top here and the rootstock on the below here. I think you've taken note. Is it okay, or I can proceed?
Yeah, it's fine.
Okay.
Bakai.
Okay. This slide brings us to the conclusion. It's very brief. As explained at the beginning of this meeting, this robot is not only the first one to be in practical use, but it's the largest one and the most compact robot so far in the world. And it's very easy to use. So as you have agriculture project going on in India that you involved in, our president did highlight that we're really interested into working with you to make that project a successful one, and by the way, contribute to the development of India. That being said, the only thing left, we want to thank you for your attention and for this opportunity again.
Arigatou gozaimashita.
Thank you.
Bakin, yoi.
読んでみる。
Bakin.
Now we are we are going for the open discussion and question answer session. And eminent scientists from the university, if they can ask, or NAHEP team members, please ask your questions. So actually, we have seen the rotary type of grafting machine on your website. That is, it can be able to graft the multiple plants at a time. So should you have available with that?
スライド閉じればいいのに。スカイプからか
Hello.
Yes.
Sir, we have seen gone through your website. We have seen that there is a rotary type of grafting machine, a large rotary type of grafting machine with your company. So have you manufactured it? Is it available that can be able to graft the multiple plants at a time?
Your question is regarding the, if I understand your question, it is about the type of plant this machine can graft.
Yes, sir. Actually, we have seen the rotary type of grafting machine, centralized. Would you have that machine manufactured?
Okay, please hold on. I need to check that with the team.
ロータリータイプのですね、チップマンタみたいなダダダダダダそういうの持ってないか。全自動や。全自動ですね。持ってないって書いて大体です。
持ってるけども、はっきり言ったらもうこれをモジュールにしてビデオ見せれるの。
それはちょっと準備してないんでちょっと無理。電蔵機持ってるのは古いタイプの電蔵機のビデオ。
これは作ってたよ、ちょっと見せた。
それ
見たよ、多分。
見たいんです。
あんの？
まあ、あれやったらできるんであれば、まあ、できるって書いておいて、後で動画を送る。
会社の方針としても、それはそっちの方向に行かないことで決めたんですけど、こういうのを開発してましたっていう参考の動画として、
そういうことを作ってたけどな。そういう今
Okay, please hold on. We're looking for some video.
About rotary enjoy effector. Rotary enjoy effector.
Rotary and in manufacturer.
You mean rotary and? Mic. Sorry, I think your mic is mute.
なんかスカラーロー
エクスパイル動きみたいなこういうやつですか。今の動きそうですね。エクスパイル。
Rotary enjoy effector.
Hand effector.
それは開発中ってしか言いようがない。
ロボットのあれですか？高野説のロボット。そのロボットやってるやつなんかあったよ。あります。あれちゃんと見せてね。
Okay, please understood your question. We're checking it.
Yeah.
専用機やってたけど、それはもうやめて、今これをモジュール化してフロートにする。林これペラペラしゃべっていいかな。まあでもこの次からもないとできへんからいいわな。引っ張るみたいな。専用機のやつちゃんと見せちゃったよね。これやったいう話は意味がある。
Okay, please hold on while they check in if there is some video we can show. But by the way, can you briefly explain again the agriculture project you're working with the World Bank?
This is a project. This is a project for the thematic research, wherein we are developing grafting robot technologies for postgraduate students, researcher students, and faculty who are checking different species of the plants. We are habituated with the vegetable grafting, and we are also inspired with horticulture, plant species grafting like citrus species, citrus plants grafting. Okay, Bakin.
Oh, okay, understood. I understand the project. It's a research project that you're working on to develop grafting technology and
vegetable plants, cucurbitaceae, solanacea plants, and citrus plants.
柑橘系ですね。柑橘系とあとナスと、ソラニーズって言ってましたよね。ソラニーズ。ナスか。
so you said citrus plant and what?
Could you repeat again? Sorry.
Mango plants. Mango, sapocha plant.
What do you mean by sapocha?
Sapocha is Dr. Dheeraj Kadam, can you tell me the botanical name? Dr. Dheeraj Kadam? Dr. Dheeraj Kadam? Dr. Tambe sir?
Sir, you can.
Hello.
Sir,
Hello.
please search out.
Tambe sir, can you? Yes.
Hello. It is a RHS.
RHS, yeah.
Yeah.
RHS. Camera thoda maag gaya. RHS.
Okay.
Hello. Regarding the hello.
Yes.
In Maharashtra, in India, particularly in Maharashtra, we are having the major fruit crops like sweet orange, then mango, then in sweet orange, then guava, and mostly it is essential to bird or graft the nucellar variety of sweet orange on Rangpur lime. And you know that is a very hazardous and laborious job by manual point of view. Hello?
Yes.
Hello?
Yes.
Please continue. That it is a very hazardous and laborious job in citrus. And you know, hello?
Yes.
Hello, you know that in the citrus, we are facing the problem of citrus decline, and for that we have to use the Rootstock Rangpur lime. Rangpur lime is Citrus limonia. That is a botanical name of Rangpur lime. And you know that the citrus decline is complex, and it complex means it is maybe due to Tristeza, Phytophthora, then Gomosis. So many problems are there, and for that we find that in research last 50 years that this Rangpur lime is the best rootstock for citrus.
Okay.
Here we are using that for mandarin as well as sweet orange. But to attain the buddable size for Rangpur lime, it takes too much time, more than 9 months. So we have to reduce that time which required to attain the buddable size. So that we may use this grafting machine at earlier stage. And in particularly mandarin, where the Center for Excellence at Citrus, and that to be at that is at Nagpur, they have developed this shoot tip grafting in citrus. So based on that, we can use this in
by using the robotic grafting. As far as mango is concerned, we are using stone grafting, and here in Maharashtra, in Konkan region, we have the Hapus, that is Alfonza, and in Marathwada and some part of western Maharashtra, we are using the Kesher variety of mango. For that also we need the grafting. It is possible to use the robotic grafting for mango in Maharashtra. And as far as vegetable grafting is concerned, you know, in throughout the world that two families, that is Solanaceous and this Cucurbitaceous, that we are success, and in we are doing some PhD work with the help of PhD students for grafting response as well as salt tolerance response also. Okay.
Okay. Thank you very much for your explanation.
I will tell about.
Sorry. Sorry. I need to do some interpretation of the content to my colleagues.
Yes.
Okay, I need to. Okay, please give me a couple of seconds.
Bakin.
ऑनलाईन आहे कसं काय कोण म्हणजे काय विषय अरे रोबोटिक
Hello.
Yes, sir. Sir.
Hello, Gopalji, whether the demonstrations we are showing or what is the next piece?
Demonstration आता झालंय, आपल्याला व्हिडिओ पण पाठवलाय त्यांनी.
Okay.
We will have just discussion, technical discussion, what can be the possible crafting technologies. From technical side, our team is discussing about how different mechanisms can be involved.
Hello, Gopal.
Yes, sir.
Can you crops they were handled in the Japan among the vegetable crops and the fruit crops? Which crops they are mostly handling in the Japan?
Yes, sir. Yes.
The range of crops which they have been handling in Japan with the robotics. Can you give them the idea or the list of the crops which they have been handling?
Yes, sir. Right now I will tell
Please.
them.
Yeah, ask them.
Hello. Am I audible?
Yeah, the robot is for tomatoes, I told you.
Shivasankar, please, can you
can check with them. You can check.
Shivasankar sir will answer this question as Honorable Vice Chancellor sir asked about what species Japanese people handle on their agriculture field.
This one.
Yes.
Both from vegetable groups and the fruit crops.
Vegetable
Both.
and fruit crop.
You can check with them.
Hello, Shivasankar sir, you are audible?
No, you can check with them. No, that is the grafting for tomatoes. But you can check with the team. KKK.
Hello, Mr. Dillo sir. Hello, Japanese team, Mr. Dillo sir.
Hello, sir.
Have the list something.
Soko ni imasuka.
シェアスクリーンして。
Yes. Hello. Hello. Sorry.
Yes. We like to know about horticulture crops and vegetable crops are handled in Japan for grafting.
Okay, okay. If you wouldn't mind, I want to get back to your question about the rotator robot. We have the video now. We want to share with you, if you wouldn't mind.
Bakin.
どれや？
USB ドライブ、あ、そうか。そうじゃないですね。
それの
D か
それの左の下。
それをシェアじゃあかんです
動画自体。
いや、USB ドライブ。
USB だとフォルダを見てるだけになるんで。
そこから開く。ダブルクリックして。あ、それでいい。それで下の方。OK。
シェアされてるの。シェアされてるの。
Can you see the video?
私たちは、
見えてないね。
Please start.
見えてないですか？
見えてないです。
ビデオがシェアされてないんで、ニューシェアで。ニューシェアで、
それ。
で、シェアです。
あ、ちょっとこっちは強引に消える。OK。見えた。
Okay, can you see the video now?
Yeah.
Okay.
Bakin, you are
呼んでんねんな。あんまりヘラヘラあったら失礼やですよ。ごめんな、5回撮ってんねん。喋れへんの後ろで似たって言われてるの確かないんで、僕は不動先生怒られてもちょっと。
これはプロトタイプ機でもう今は作ってない。
今作ってない。でもまあこれは作れるけど、これはもうちょっと現実的でないから。
スーロープレイ。
すいません言うて。すいません言うて。すいません言うて。ちょっと待ってくれ。Excuse me 言うとんねん。
Okay.
Video suru puroi. It's a slow play.
Slowly.
Yeah.
こんな機会が存在するのは言ったらびっくりするんだと思う。じゃあ、うちの会社の実力的には見せれるんや。
ここにありますかね。スローっていう。
ロボリました。
あ、スロープレイあったわ。あれ今それ見えたっけ？
ないですね。So sorry. Oh.
It's not playing.
It's playing now.
Yeah, play it slowly. It's not. You are not push the button of play. Please push the button of play.
It's playing.
覚えてないですね。
それは分かる。
写真だけ写ってんのか。それでプレイ言ったのか。
Replay.
違うのが止まってるんですよね。
通信が悪いんですかね。
今狭いから。
容量が大きいから。あ、プレイボタンって書いてあるんです。プレイボタンを押してくださいってなんか向こうから来ましたよ。押してるよね。押してるんだけど。
Hello,
Yes.
hello, Japanese team.
Yes.
Can we be able to which type of plant we be able to graft by this robot?
バッファして落ちないよ、バッファ。あそこがプレイボタンになってたっていうのは押してなかった。
Hello,
Hello.
hello. Sir, which type of plants we be able to graft by these robots?
今動いてます。
これはトマト。
トマトです。
Yeah, for this type of machine is only tomatoes.
Can it be for eggplant? Eggplant.
ナスはできるか。
Yeah, yes, for eggplants also okay.
Yeah. Yes.
They are grafting the 8 plants at a time.
Water lemon also can be
ウォー
possible.
ターメロンは、ウォーターメロンはできない。
Oh, no.
Not now. Not now.
No, not with watermelon.
What is the probable diameter of that root and stem? Should we be able to graft by this machine?
What is the question, please?
Sir, what is the diameter of the plants we be able to graft by
I know.
this machine?
規定を教えてくれる。
1.7から2.3。
Diameter of
1.7
1.7、そこに書いてあるんですよ。1.7から2.3って書いてある。
さっき見せてたやつ。
それで。
1.6の2.2って書いてあるけど、1.7から2.3で、5枚ずつ両方数える。
It's in the range from 1.6 to 2.2 millimeter.
1.6 to 2.2 millimeter.
Yes, that's for the both the Scion and Rootstock.
Scion or rootstock. Can you able to increase it more than 2.2?
以上は
2.2 以上にできませんか。
More than 2.2.
でもこれ言わなかったから、この装置は昔作った今作ってなくて、次のちょっとビデオ見てくれ。さっきの。
Very 2.2.
できるかって話ですかね。
Very 2.2 millimeter.
それはできるやん。できるけど、ちょっとこれ言わできる言っとって。
Yes, it can go beyond to 2.2.
Yeah, we can go beyond 2.2.
Yes.
Barking.
Can we be able to use this for the hardwood type of plants? Hardwood grafting.
ハンドリングロボットのビデオ見せたって。
あれ、
Hello, sir.
動かさんと認識せえへんみたいなんで、こっちのビデオをさっき動かしてからシェアしに行かんとあかんね。
これですか？
そう。
で、そうすると、
Hello, sir.
ところに。
Hello.
そこに出てこないからね。
動いてないですね、今。動画。
言ってることは言ってるね。
バッファリングしてるんちゃう？データ飛び込んで。
Now, Mr. Dallo,
Yes.
our Honorable Vice Chancellor is asking about which plant of vegetable plant and horticulture plants are grafted in Japan.
日本で何をなって
どういう、次。
で、自分に行くかな。トマト、ナス、
エッグプランツ。はい。
トマト、エッグプランツ。それから、ペッパー。
To answer to the question of the dean, I think, about the type of plant that are grafted in Japan, it's basically tomatoes and eggplants and some paper.
They're vegetable.
Yes, vegetable, basically.
And horticulture,
ウォーターメロンもある。
ウォーターメロンはありますけど、まあ、
キューカンバー。
rootstock. I'm talking about
花はやってないので。
And there are some watermelon and some cucumber.
cucumber,
Yeah.
watermelon,
Yeah.
Yes, and tomatoes.
tomato.
And yes, that's a vegetable.
Okay, only watermelon. Only watermelon. Any other fruit? Any other fruit? Plant?
フルーツになってるんですね。
それだけです。
Any other fruit?
No food.
Then we will go for
No
six
fruit.
fruit.
メロンもよ。メロンも OK。
メロンもいける。Oh, sorry. Melon also.
Yeah.
ばらつきやっとんです。
その他なんかようわからん。
Dialogue.
本に出てきて
Yes.
We can work together for citrus plant grafting as Rangpur line. Rangpur line is an Indian species. We are having scientists to work for the citrus group of the plant species for grafting.
Oh, okay, okay.
This will be innovative project.
別の時に、今柑橘系の
レモンとかオレンジとか一緒に研究したらどうですかっていう。
何をしたらどう？
なんてマンゴーとかレモンとかオレンジとか
ライム
の、ライムとかの接ぎ木の開発に一緒にやったらどうですかって。
ちょっと。
家事はちょっと。
いやいや、日本でちょっと言ってない。日本で花とか。
Gopalji.
Yes, sir.
やってるけど、ちょっとまず
Gopalji.
そのたくさんできない。まずベジタブルから進めましょうよ。それじゃない。
Hello.
Sir,
Yes, yes.
Hello.
Dialogy. Yes, Mr. Dialogue. Dialogue.
Yes.
Please listen. Please listen. Sir, please continue.
Hello.
Sir. Continue.
Yes.
Hello. May I ask any question?
Yes, sir. Yes, sir.
Mobile थोड़ा दूर धरा. Mobile दूर धरा, sir.
Okay.
Yes, sir.
Hello.
You can ask. You can ask. Sambe, sir, please ask.
Sir, my question is mostly in vegetables that Solanaceous as well as Cucurbitaceous, these all Scion as well as rootstocks we can grow easily. And when we are going to graft it, then I would like to ask one question that whether the Scion as well as rootstock we should have to grow on pro tray or small size bag. Pro tray or small size bag.
You know,
size back.
One size big じゃないですか。
Yes. Can you repeat the question, please? Sorry, I couldn't.
So whether my question is because why I am asking, because the rate of grafting is 800 per hour. This robotic grafting.
Yes.
So to handle these bags while grafting, whether we should have to grow Scion as well as rootstock in pro trays or small size bag. If small size bag, what should be the appropriate size?
If I understand, you talking about the bags where you need to put the grafted plants once the grafting is completed. Is that your question?
Yeah.
Hi.
Hello.
その接ぎ木終わった時に入れる容器のサイズどれぐらいか。トレイ、はい。
What should be the appropriate size of bag? Small sized bag.
現物持っていきましょうか。300×600 ミリ。30センチ ×60 センチで、セルのその中にセルが128から200あります。
300×600
300ミリ ×600 ミリ。30センチ ×60 センチ。
はい。の中に、
セルが128から128か200の2タイプ。
この 300×600 はトレイのサイズ。
トレイの大きさ。その中に小さいセルが128あったりの場合と200ある場合の2種類。
OK。
300×60で、ここのキャビティが128個のタイプとあと200個
2種類が。
2種類。
Okay, to answer to your question, what we're using right now is the tray. And the dimension of the tray is 300 millimeter multiplied by 600 millimeter. And inside the tray, you have two different kind of cavities of 28 millimeters and 200 millimeters.
These are the to say 28 and 200 millimeters.
Yes, two different kind of cavities inside the tray.
And the tray size. And the tray size 300 by 600 millimeters.
So, sorry, what's your question?
The tray size is 300 by 600 millimeter.
Yes.
Yes.
Okay. Okay.
Cocoa peat, there are two cavities, 28 millimeter, 200 millimeter.
Yes, exactly.
個数。
No,
128。
no, that's not in millimeter. It's the number of cavities.
Oh, number, 200 number.
Yes.
Yeah, and Babuno size.
So, sorry, what's the question?
Bag size.
The
Plastic
size of the cavities.
Yeah, if we use plastic bag,
セルの中にこう袋を入れるんですか。
さっきの動画の説明をさっきしないと、あれもやってないっていうので、これ映すと、まずトレーのイメージがもう一目瞭然で。
この2つ目。
映ってると思うんだけど。
映ってる。
白いのが映ってる。白いトレー。これだよ。この時今やってない説明を。
Sorry, can you see the シェアしてる。
シェアしてるのはロボット、あれ、システム機やから、内需本の方をシェアしてるとは感じ。してんねん。
Yes.
だけど、こっちに。あ、そういうこと。それ映ってるんやったら。
Seedlings. Then what is the size of bag? Plastic bag.
Sorry, yes, that's what I'm looking for. Some video here to show you, so you can have a better idea of.
I think we should focus on the fruit crop grafting.
Can you see the video here?
Yeah, please play it. It's still running. You play it fast. Yeah.
Okay. Can you see?
Yeah.
That's the tray I was talking about.
Yeah.
Here.
How do we get this tray? Can we manufacture?
Yes, うちが作ってるんですかね。
これは普通の市販品。
In Japan here, you can have it on the local market.
Oh, so if we learn the manufacturing of this tray, we can manufacture it in India.
Yes, hopefully.
Hopefully, yeah. We have a 3D printer.
Sorry, what's your question?
We have a 3D printer. Can we manufacture these trays?
Yeah, 3D プリンター持ってるんですけど、これもこっちで作れるか。Yeah, I think you can.
Yeah. And what about the clips?
What?
To join Scion and Rootstock, we need a clip. Is it a tubular clip or is it an anchor? What type of clips we are using for grafting? What type of clips we are using for grafting?
Clipはどうする？So the clip will be sent from Kusakabe.
Oh, it's your patented. Your patented clip.
Sorry?
Is it patent
パテント取ってない
in India?
取ってますね。
インディアでは取ってるんです。
we have, yeah, it is patented in Japan here, but I don't think in India that will be in the future.
We have the design of the different clips for this grafting.
Different size of the clips.
Is there any effect to tray cavity dimension of grafting? Is there any effect to tray cavity?
No, sir.
Good.
If you change the cavity dimensions, then whether it will affect on grafting, whether we can change the tray dimension.
You mean if you can change the dimension of the tray on your own?
Yeah, exactly.
それ、
で
きるとないことはないんですけど、向こうがそのトレイのサイズ、自分で自由に変更できるかどうか。
自分で変更できるかどうかっていうか、今のビデオでやってるやつには、トレイのサイズはそう関係ないですけど。
変更できる。
You can find some questions. You can find some questions in chat box that you can read. Please, if you could answer it. Please,
okay.
Share your answer. Yeah. Can you change the dimension of tray or tray cavity according to our size?
Yes, Doc. Yes, Patil sir. He has said that we can change. We can change, but optimization of that cavity they have already studied and done. So no need to go for change. If you want to change, you make your custom design according to the plant, the size and specifications.
Whether
exactly.
Whether change the dimensions are compatible to our robot or not.
Yes.
Is it compatible? If we change the dimension of tray, then whether it is compatible,
yes,
to the existing robot that we have purchased.
Hi.
Yes, I think he answered the question. It's okay. You can proceed like that to adjust to fit your requirement.
The next question is, can we make this entire setup movable?
苗を育てるのにプラスチックバッグを使うことができるかどうか、使えるかどうか。
Sorry, can you repeat again the question?
Can we make this machine setup, grafting robot setup movable by wheels?
Wheels.
Portable. リースできるかってことですね。
まあ、下に動できるように、なんてやれ。なんてタイヤ付きみたいなやつ下で。
手で持てるから必要なの。
そうそう。移動は。
Hello.
Yes.
5キロぐらいしかないから。
何キロ
Hello.
50キロ。
ぐらいしかないから持って運べる。
You know, I don't think why you will need that, but the weight of the machine is just 25 kilograms, so I think 2 people can move it easily. いいですね。
Professor,
Hello.
please.
Hello. हाँ गोपाल जी.
Sir, थोड़ा मोबाइल दूर क्यों बोला?
हाँ. My question is, hello.
Yes.
You know, in robotic grafting, we have mostly whether the robotic where they are using, mostly they are using 2 types. One is by using clips and another is by using pins. Okay. First clips and then pins. So mostly what happen, if the size of stock and Scion is variable, then it is very difficult to success by using clips. So whether that clips are adjustable according to the size of stock or Scion, or under such circumstances, whether we should have to use pins for better success. Do you got my point or not?
So what you're trying to highlight here is if we want to change the requirement to adjust our needs, we need to use fins instead of clips.
今のおじさんは何の植物に関して言ってるんですかね。
Whatever the experience we have, when the size of Scion and stock having a variation, then it is very difficult to adjust the clips after grafting. The grafts are failed. So,
okay.
So whether whatever the available clips are there, they are adjustable according to the size of stock and Scion or not?
Okay, so the point you highlighted, is it with regard to vegetable or what kind of plants?
Mr. Tylo, I will repeat his question in a simplified manner. He is asking about whether this clip is adjustable to diameter of the plant, as the diameter of the plants are varying with dimensions. Can it be adjustable? Talking about pin.
多分茎形差があるときにピンの方がいいんじゃないかって言ってる。ピンか。
Adjustable.
ピンか。
どうですかね。
いや、金継ぎやから適当に言ったらいいと思う。我々の実験では金継ぎは結果がよろしくなかったんです。だから日本ではピンはほとんど使ってない。
Okay, to answer to your question, as for our experience in Japan, usually clips are used, but not pins.
Hello.
Yes.
Yes.
Do you hear me?
Yeah, now here. Please repeat.
I mean, in Japan here, usually we use clips instead of pins.
Okay, okay.
Sir, one more question here. What is the cost of production in terms of dollar? Cost of production. As you told that in 1 hour, your machine can graft 1200 plants. I think, yeah, I'm correct. I hope so. So what is the cost of production of those 1200 grafts, grafted seedlings? Cost of production, I'm asking.
200とかなんだかんだ。
これですね。この400のところで、で、これの
you can tell in N also, N. In your currency also you can tell, no problem.
You're asking the price of the machine or
Price of unit plant cost.
Cost of 1,000 grafted seedlings, I'm asking. Suppose if you are producing 1,000 grafted plants, then what will be the production cost? What will be the production cost?
If I understand, that's a bit difficult to answer because usually we're just limited to supplying the machine, and our client is responsible usually for buying the plants and all design and rootstock. So it's difficult to give an answer on that.
It's okay.
No, what
Sir,
is
how?
Dr. Dilo?
生産にかかるコストでしょ。ね、生産にかかるコスト。金代とちょっと違ってんなと。消耗品ちゃう。金代とか何かやってきて。
Yeah, but if you ask, for example, what kind of spare parts comes along with the operation of the machine, and he does it. We can have an idea about that, but for the cost related to the plants, it's difficult to answer that.
Mr. Dilo,
Yes.
what is the price of unit plant, grafted plant cost in Japan?
日本ではどれぐらいかの話。難しいな。海外は
Sir, can you tell me the machine capacity per hour, machine capacity, grafting capacity of this machine? Grafting capacity of this machine.
1時間で1時間で400本。
It's 400 grafted pieces per hour for one operator.
Yeah, that's fine. 400. So what is the production cost per hour production cost? I'm asking.
For one cycle.
What is the production cost of 400 plants?
コストって言われてもな。
What is the cost of one batch plant production cycle?
I understand your question, but
Or
you know,
you can tell us what is the unit grafted plant cost in Japan?
you know, for the question, yes, the question you asking, to answer that, first we need to have the price of the plant that are being, you know, grafted.
For example,
it's difficult.
難しい。
難しいね。You know, this depends on the type of vegetable you grafting, and you know, it's difficult to answer it.
Yeah,
Seriously.
Mr. Shinde ji.
yes, sir.
Shinde ji.
Yes.
Actually, it is localized. That's Muskashi. So that's localized. You have to see from your side, not from Japanese side. That is not okay.
Okay, that's fine.
That is not okay. So you have to see your cost from your side. No, it's not okay. So that's Muskashi.
中の光熱費もありますからね。
The Indian side you have to see.
What is the break even of this grafting robot machine? What is the break even?
You have to calculate. You have to calculate. They have given you 400 pieces. You have to calculate it. From your input cost. So you have to calculate.
Okay, I will leave that to Mr. Shiv Sankar-san.
Yeah.
200本だからっていうのを言ってあげたらいい。
That's a Indian local. So Shindeji.
Yes.
So, that's a localized Indian input cost. So not comparable to America, Japan. No.
ディアロさん、手継ぎでは日本ではトマトの継ぎ木は1時間1人200本できますと。でもこの装置は1時間で400本なんですよって、just for your information でなんか言ってあげたらあの人満足するかもしれない。
Sorry, just to add some information, there are of course some other grafting machine in the local market in Japan here, but usually their productivity is 200 pieces per hour. And if you compare that to our machine, it's twice.
Oh, but I had an experience of HRC grafting robot from South Korea. They are producing 800 pieces per hour.
Oh, really?
Yeah, I'm having experience. 800 pieces per hour. So you cannot say double the price. The price is the same as your price.
でもコリアのやつはオペレーター2人だから1人にしたら400本ですよね。
But did you realize that the machine from South Korea require, of course, it is 800 pieces per hour, but it requires 2 operators. But in our machine, it's just 1 operator. So if you put that together, in the end, you have the same productivity rate.
Yeah.
僕がまた違う。僕が半分ぐらいやるとき。
Two operator, one operator is the positive point of KKK.
Yes, yes, it's 400 per one operator, but for self-current is 800 two operator. So in our machine, if you double, you put two operator, you get the same production rate as the self-current machine.
Yeah. Yoy.
Hello. Yes, sir, my question. Hello.
笑ってないで介入しなさい、君。
Okay. Hello.
Yes. Yes, Mr. Rahim Khan. He is a grafting technical expert engineer. Mr. Rahim Khan, please.
Yes.
Okay.
Sir, my question is, can we make such arrangement that we can identify the seedlings which are affected by any disease or pest before the grafting? So it will reduce our practices to make the disease one plant to separate before the grafting.
Mr. Dilo is asking about whether there is a sensor applied in grafting robot to detect the pest, and separate it from the grafting process, which is infected.
消毒の話。
そのセンサーとかがついてるかどうか。
どういう関係なの？
それを認識するような機能があるから。
それはない。それはない。ただ、消毒液をアプライするような機構はある。ただしオプション。オプションとしてですよね。
Oh, okay. For detecting, the question, we do have an option on the machine for applying.
We have a solution. We, our university scientists have a solution to detect the pest at the time of grafting, so as to remove that plant which is disease infected.
So what are you trying to say with your research? You have find a way to detect the pest and remove it
before grafting. A pest detection by sensor.
As if we grafted the infected seedlings, we know that it will not survive. These vegetable seedlings are very sensitive to the disease and the pest. So it will be better for us to remove before the grafting. So it will reduce our cost of production.
It's a question of mortality.
Yes.
Mr. Dilo.
Yes.
It's a question of mortality. If the plant is infected by disease and we get it grafted, the plant will die and there will be increase in mortality. So before going for grafting, we go for the plant disease detection, pest detection by use of sensor on end effector.
Okay. That's amazing technology.
Yeah, we like to associate with you in this regard to make the mutual collaboration. We all are with you, and you feel it with some work experience with our Vasantrao Naik Marathwada Agricultural University scientist.
Okay, for that pest detection, is it on vegetable or any kind of plant?
Any kind. We have a disease recognition expert system scientist. Doctor, one of the co-scientist member can join. May I know who is presently online? May I know who is presently online? From entomology, genetics, from anyone who can share his view. Dr. Dheeraj Kadam. Dr. Dheeraj Kadam, Are you there? Dr. Dheeraj Kadam?
面白いです。
総力戦でも前に、追記前に。
Dr. Dheeraj Kadam?
Okay, Shinteji, no problem. Don't worry. Just.
So any more question from core faculty, from NAHP technical staff?
You
can always extend the mail.
Sorry. My second question, sir, last question. Yeah. If we use the rootstock, or the plant will die, means it will not got success. So can we utilize it for the second time for the grafting, or can we have to throw it? Once we use the seedlings for grafting and we make the graft, and after as our what we said, due to some problem, the grafting is not successful. So can we use the lower part again for the grafting? Hello?
Rahim, can you
Yes.
make question very short to understand them? Can you
Yes.
make pinpointed words?
Yeah. Can we reutilize the rootstock if the grafting got failure?
With Scion.
In case of
With Scion.
rootstock, the lower part, can we use for means if we got a failure of grafting, then we can reuse that one, the lower part, the rootstock, or we have to use the new one?
Mr. Diallo? Is there any connectivity? Mr. Diallo? Yeah, Mr. Diallo, are you able to hear me?
Hello, anyone from the Japanese team?
I think they are discussing.
Yeah, because of the range problem.
Yeah, connectivity problem. My laptop's gone.
Okay.
I'm using mobile now.
Yeah, it was very nice warm-up discussion, and we are very much appreciating.
Sorry.
So we have to come to a close, Shindeji. So.
No, just now Mr. Diallo is online. He's connected. Mr. Diallo?
Yes.
He is asking one question about if the grafted plant fails at Scion, can we reuse rootstock again?
So to answer that question, we would like to first confirm one thing. What do you mean by failure? For example, you cut the Scion and you cut the rootstock at the stage of grafting. You realize that there is failure.
And Scion is failure. Scion is failure.
Before grafting.
After grafting.
But after grafting, usually it takes a couple of days before realizing that whether the grafting was successful or not. Usually, I think 2 days or 3 days.
Yeah, as if after 2 days, if it fails, can we reuse rootstock? Can we reuse rootstock?
No, in that case, we cannot.
Because rootstock has already gone its property. To begin with that rootstock case. What is the mortality of this grafting robot? Mortality in 400 plants batch.
You mean, okay. それあるんですかね。いや、例えば1時間あたりに400作りました。その中に、こう、なんて死んでいくやつ。どれぐらいの割合
95% 以上なんで。
5%。Oh, okay. If you see at the beginning, it was 95% of successful rate. So the failure is 5%.
same as the South Korean robot they have mentioned, 95%. But do you experience this is okay?
それで OK としてるかっていうことですけど。
Do you experience?
OK としてます。
Yes, usually as per the feedback we have, it's okay. It's practical.
Practical.
Yes.
Okay.
So
May
now
I,
questions were.
may I know what are those 5% losses?
What do you say?
May I know what are those 5% losses?
Mortality rate, sir. It's a mortality rate.
No.
Yes.
Can you explain about this 5% with a reason why they are 5%? Technical fault, plant fault.
Depends on あれば、その苗の状態よ。苗の状態。苗というか、そのルートストックとサイオンとの状態というか、苗の健康状態です。
That's based on the condition of the plant being grafted.
So it differs from plant to plant, or is it a failure of technology, or is it a failure by plant?
I think it's plant.
Plant.
Yes.
So we should not blame on the technology.
Exactly. No blaming room for the technology.
Yeah, we should not blame.
So I think.
Gopal sir.
Yes.
One question, very simple question.
Yes.
Is there any sensor available with that machine to identify the male and female plants? Because in papaya, we are interested to buy more female plants instead of male. Is there any sensors, inbuilt sensors in that machine to separate out that these are the female and male?
Okay, Mr. Dilo.
Yes.
There is one question. Can we detect a male or female plant species on grafting robot? Can we?
No, the answer is no.
So from our side, answer is yes.
We can do it.
We can do it by artificial intelligence kit.
Really?
We can put an artificial intelligence kit to detect male and female.
Even by using the biotechnology approach, we are able to find out the male and female. I think.
Can you explain the process? How you do that?
We make a picture of male and females, more than 10,000 pictures, which will specify and classify male or female by logical interpretation.
Yeah, I mean,
which is on machine vision based system. Machine vision.
見たらわかる。マシンビジョン画像処理してわかるんですけども、それが何の役に立つのかわかんない。
大丈夫ですか？
大丈夫です。
大丈夫です。
なんか水だけ欲しいけど。
それ。Yes, yes.
トマトじゃない。
イチョウの木だと勤めそうです。ベジタブルがない。
Anyone having any more question, please? From our side, team member, if anybody is having any more question, please ask. We are about to close the meeting.
No, I would like to ask one question.
Yes, sir, please.
Okay, I understand you're doing a lot of research on grafting, but I would like to know whether you're involved in any practical project or grafting, agriculture project in India.
You mean to say experimental practice or technological built-up practice?
Let's say
Experimental, we have a eggplant, grafting, eggplant grafting. Then
Yes. Can I explain, sir?
yes, please.
Yes. What we do, we have grafted the wild variety of eggplant to our local cultivar to just make the study as the wild species required very less amount of water. So can we make the combination or grafting of these two species to a single plant? And one of our PG students, Ms. Jyoti, has under the guidance of
Dr. Tambe.
one of our, Dr. Tambe sir, she has completed 1 year what we say research. So the results are amazing. So we have grafted this wild species to our local cultivar of eggplant, and we got a good success. So on the next experiment, we will do the grafting with the help of this vegetable grafting robot, and we will continue the next year research project.
Okay.
And now we are proceeding to the species that we are just now mentioned about the Rangpur line citrus plants as per the guidelines of Honorable Vice Chancellor Dr. Dhawan sir, and also Dr. Tambe sir is helping us in this regard, and we will be proceeding to go for Raipur line indigenous citrus plant species, rootstock, and then Scion also. We are having these all practices.
Okay. But by the way, one more question.
Yes.
What is the grafting machine demand in India?
If we VNMKV team lead, then definitely it will be a great pleasure that every nursery will be automated by grafting robot. Every nursery in India, and we gathered the more than 30% of the nursery people who are doing well, they need grafting robots. So we will be integrator and hub for Japanese grafting robots in coordination with VNMKV. So this will be a mutual.
Provided Gopal, the
Yes,
technology should be user friendly.
Yes.
And reasonably cheap. It should be reasonably cheap and user friendly.
Yes, sir.
Then there's a tremendous scope in the Indian market. There's a tremendous scope in the Indian market, provided the technology should be very user friendly, easy to handle, and at the same time it should be relatively cheaper.
Economic, yeah.
Yeah, because our land holding is very, very low.
Very low.
There
Yes.
are very, very large number of private nursery players, and they will be very happy to have this kind of robots for the grafting work.
Okay. By the way, is there any PPP project? With the public and the private partnership to help bring down these costs related to grafting down.
It is just a beginning in India. I would say the robotics is just a beginning in India, but in years to come, when the government interventions are there, to begin with, the public-private partnership venture. But in the long run, it has a tremendous potential.
Okay. Because I think the challenge here, as you indicated, of course, it has to be user-friendly, but it needs to be also cheap. And the question is
not in absolute term. It is in a relative term. Reasonably, I'm using the word reasonably cheap.
Okay.
Should be economic justifiable.
Yeah.
It's economic, reasonably.
Yeah.
Plant production cost. That's why we are asking about the plant production cost. The unit cost of the plant should be affordable by farmer and the producer too.
Okay.
Yeah.
You indicated earlier that when grafting machine for nursery, is that a governmental project or it's just some sort of forecast?
No, it's a direct government project. This is a World Bank and direct government project where we are establishing a center of excellence to proceed the agricultural to progressively lead the agricultural entrepreneurship through this center of excellence.
Okay, that project is has started to operate, or it is in the phase of conceptual phase.
Yes.
Conceptual phase.
Hi. Yes.
Okay. Thank you.
So Shindeji.
Sutokina discussion.
So no, so we have given the offer to you. I hope you will process it.
One more question, Shinde sir. Any other agriculture machineries that you are manufacturing at your company? Apart from grafting robot?
No, for now we're only manufacturing grafting machine.
Any other
No,
agriculture machineries? Yeah.
Sir,
yes.
Can we have a mutual partnership, a project of this robot manufacturing? One is in India, here in university, and one is in Japan, KKK campus, Osaka.
Okay, I'm not able to address any thing on that. We want to request you to we have discussed here about a lot of things, but we would like you to send some sort of document just for one page, highlighting the objective of the partnership and in which area we're gonna have that partnership with that. It can help us to further evaluate it and try to see how we can bring out know-how with you and work on this project.
We will go for this discussion in detail in the next meeting, because we will gather and discuss with our Honorable Vice Chancellor, and we will let you know about this in the detail. But soon we will proceed with the documentation. We are very serious about collaboration. Okay.
Yes, we do. If you have heard, our president also did say the same thing. So I think with that document highlighting the purpose and objective of the partnership, if we could have that, it would be really helpful.
Hi. I think Vice Chancellor.
We have to close.
Yes, sir. Shall we?
Will guide us if Vice Chancellor sir is giving us permission to close down this meeting.
Absolutely. I think we had a nice discussion.
Yes,
and
sir.
we continue to hope that we will have further discussions in due course of time. Despite my little engagement at the home, but I still enjoyed the discussions and the participation in the program.
Thank you, sir. Thank you very much.
Thank you very much.
Thank you very much.
I hope
Presentation as our message, Sutukina presentation, Bakin. We will be continue to have these discussions hereafter frequently, and we will go for the documentation process. I think Dr. Shiva Shankar sir, do you want to say something?
No, we have given you the offer, so we need the order.
Yeah, well, yeah, we will have that.
It's a business model, business model. Yeah. You may have to process. So this is a preamble, no? So
sure. So, Mr. Kemchan, will you please proceed for the end of this discussion? Before that, Mr. Diallo.
Yes.
shall we close this meeting now, or you want to say something? Your team want to say something?
For now, the thing we would like to say is to thank all of you for giving us this opportunity, and it was a good time to exchange with you on the grafting technology, and we're really excited about this partnership. And again, we would like to thank you for this opportunity, and we hope we're going to have further discussion in the coming days.
Thank you, sir.
Thank you, Shinde-san, for the initiative taken.
I hope everybody is satisfied with their doubts, and we will continue this discussion afterwards.
Just a minute. Yeah, just for a while, 1 minute, Mr. Khemchand. First of all, I would like to say in Japanese.
Yeah, Shinde-san.
You are not audible, sir. Shinde sir, you are not audible.
Yeah. Okay, shall we?
Decision making and
Okay.
One more, please.
One thing I would like to add.
Yes.
Your question about the handling, at the very beginning you were asking about handling, if you remember.
About?
The very beginning.
Pardon? Can you please repeat?
At the beginning, you asked a question about rotatory robot with handling, some sort of handling.
Yeah.
Yes, for that handling, actually, recently we're conducting research on that. We're working on it. So, yes. So that's the point I wanted to highlight.
Very much pleasure. Yoi, barking. Arigatou gozaimashita. Sutokuna discussion, presentation. Thank you to all of KKK members. I will just invite now Mr. Hemant Rokre. Mr. Hemant Rokre.
Yes, sir. Good afternoon to all.
Thank you, Shinde-san.
Just a minute.
Hello. Good afternoon to everyone. On behalf of NAHEP-CAAST-VNMKV-DFSRDA, VNMKV Parbhani, I extend my vote of thanks to our chairman of today's meeting, Honorable Vice Chancellor Dr. A.S. Dhawan sir, who spared time from his busy schedule to grace the occasion. Dom arigato gugai masta to Kanso Minahara-san for your valuable time. Thank you very much, DI and Dean, Dr. D.N. Gokhale sir, for your presence and valuable address. Thank you very much, Shiva Shankar sir, for your valuable time. Do arigato gogai masta to Yuji Masahi, San General Manager, Agriculture Machinery Sales Division. Do arigato gogai masta to Koji Shimada San, Assistant General Manager, Agriculture Machinery Development. Do arigato gogai masta to Jugo Minohara, San Group Leader, Sales Engineer, Agriculture Machinery Sales. Do arigato gogai masta to Mamadou Oro Dilan San, Overseas Sales Division. Do arigai masto to gogai masta Hideki Murakoshi San, Group Manager, Overseas Business Division. Thank you to Dr. Jiu Shinde sir, PINHEP-CAAST-VNMKV-DFSRDA, VNMKV Parbhani, for his valuable guidance for organizing the meeting. Also, I am thankful with all deep sense to all co-PI, core team members and participants of today's meeting. We have been fortunate enough to be backed by the team of very protective and dedicated technical teams of NAHEP, Engineer Khemchand Kapgate, Dr. Narendra Khatri, Engineer Ravi Kumar Kallochi, Dr. Avinash Kakade, and all NHEP staff members who are directly or indirectly support us. With the prior permission of Honorable Chairman, I announce that the meeting is today's meeting is closed. Kono kai gyo orimasta.
Thank you, sir.
Thank you. Thank you all. Thank you.
Thank you.
Arigato.
Bye bye.